Now moving on to the conservation of linear momentum. So in a linear system, the total momentum is conserved. What that means is that the momentum before collision is equal to the momentum after the collision. So in symbols, m1u1 plus m2u2 equals m1v1 plus m2v2. Now m1 is the mass of the first object, u1 is the initial velocity of that first object, m2 is the mass of the second object, and u2 is the initial velocity of the second object. So what we have here, we've got, this is P1 and this is P2. So the momentum of the first object, and we're just going to subscript that with an I just to show that it's initial momentum. So the initial momentum of the first object plus the initial momentum of the second object, this will give us the total initial momentum, so before the collision, and then we'll have m1 v1, the mass of the first object, times its final velocity v1, and m2 v2, the mass of the second object, times the velocity of the final velocity of the second object. So this will be p1, and that's your final, and the momentum of the second object, and that's your final momentum. So the sum of those two will be the total final momentum. And this is the basis of this section. Chris and his son are skating on an ice rink. Chris skates in a straight line at a speed of 3 meters per second towards his son, who's stationary on the ice. When they meet, Chris lifts his son up and they continue together at a speed of 2 meters per second, still traveling in the same straight line. Chris has a mass of 80 kilograms. We require to find the mass of the son. Okay, so we'll have the son is the father, and the son is stationary. Chris is skating towards him at 3 meters per second. When they meet, Chris lifts up his son and they continue together. So he's skating towards the sun. Once he reaches his son, they then move off together. So they're one unit and they're moving in the same direction. So Chris has a mass of 80 kilograms. So mass 1 will be 80 kilograms. The initial speed of Chris is 3 meters per second. The mass of the sun is what we're required to find out, and the sun was stationary on the ice. That means that his initial velocity is 0. So we've got m1u1, m2u2. So the total momentum before the u2 equals m1v1 plus m2v2. So m1 is the mass of Chris, so it's going to be 80 times his initial velocity, which is 3. The sun is stationary initially, so m2u2 will just be 0. And now we have m1v1 plus m2v2. Now, the fact that they move off together as a single entity, a single unit, that means that they share the same velocity, right? So we're going to have m1 plus m2, so the mass of Chris plus the sun, times the final velocity v. That final velocity v is 2 meters per second. So we now have 240 equals m1 plus m2. m1 is 80 plus m2 times the final velocity, which is 2. Now I'm going to just divide both sides by 2. So 120 equals 80 plus m2, and therefore m2 equals 120 minus 80. So the sun is 40 kilograms. A ball of mass 0.04 kilograms is moving at a speed of 3 meters per second when it hits a stationary ball of mass 0.06 kilograms. After the impact, the first ball is stationary. Find the speed of the second ball. Okay, so we have a ball of mass 0.04 kg, so that'll be m1, has a speed of 3 meters per second, so u1 equals 3 meters per second. It hits a stationary ball of mass 0.06 kilograms, stationary, so its initial velocity is going to be 0. After the impact, the first ball is stationary, so m2 will be stationary. which means that, sorry, M1, the first ball, will be stationary, so V1 will be 0 meters per second. We're required to find the speed of the second ball. So we'll have M2 0.06, and we are required to find the final velocity of the second ball. So the conservation of momentum, M1U1 plus M2U2 equals M1V1 plus M2V2. So we'll have 0.04 times 3. Initially, the second ball is stationary, so that's just going to be 0. M1V1, the first ball after the collision is stationary, so the first quantity here is going to be 0. And then M2V2 will be 0.06 times V2. And then V2 will be 0.04 times 3 over 0.06. So the final velocity is 2 meters per second. That's the final velocity of the second ball. Box of mass 25 kilograms slides down a slope until it's reached a speed of 5 meters per second. It then travels at 5 meters per second horizontally across a smooth floor until it bumps into a stationary crate. Immediately after the impact, the box reverses direction and travels at 0.5 meters per second. The crate starts to travel at 2.75 meters per second. Find the mass of the crate. Okay, so we have our slope. Box of mass 25 kgs slides down the slope until it's reached a speed of 5 meters per second. It then travels at this speed horizontally across a smooth floor. So it'll get to that point where its speed will be 5 meters per second until it bumps into a stationary crate. Immediately after the impact, the box reverses direction, so box will move to the right and travels at 0.5 meters per second, so V1 will be minus 0.5 meters per second because it's traveling initially to the left, which we choose as the positive direction. After the collision, it's then moving to the right, so it's minus 0.5 meters per second. The crate, once it's been hit, starts to travel at 2.75 meters per second. So the crate is obviously moving in that direction, and its final velocity is going to be 2.75 meters per second. Initially, the crate is stationary, so U2 will be 0. So M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. So M1 is 25. At this point, we'll call that point A. The box is moving at 5 meters per second, so its initial velocity is 5. The crate is stationary, so we'll have M2 U2 being 0. M1 V1, M1 is 25, and the velocity, remember the box now moves to the right, so its final velocity is minus 0.5. The mass of the crate is what we're looking for, and its final velocity is 2.75 meters per second. So 125 equals minus 12.5 plus 2.75 M2. So 2.75 M2 equals 137.5, and then mass of the crate is 50 kgs. Particles A, B, and C with masses 0.1 kilogram, 0.01 kilograms, 0.06 kilograms, 0.12 kilograms respectively are at rest in a straight line on a smooth horizontal surface with B between A and C. A is given an initial velocity of 4 meters per second towards B. After this impact, A rebounds with a velocity of 2 meters per second and B goes on to hit C. After the second impact, B comes to rest. Find the speed of C after the second impact. Okay, so we're going to consider A to be, A's mass is 0.01 kgs and B is 0.06 kgs. The final velocity for A is minus 2 meters per second. B goes on to hit C. Okay, So we need to find what V2 is, right? So we're going to say M1U1 plus M2U2 equals M1V1 plus M2V2. So 0.01 times the initial velocity of A is 4 plus B is at rest, so it's not moving. Then we have final momentum for A, so 0.01 times minus 2 plus 0.06 times V2. So 0.04 equals minus 0.02 plus 0.06 V2. 0.06 V2 equals 0.06. V2 is 1 meter per second. So this is now the speed with which that B has on its approach to C. Okay, now this speed that B is moving off now is its initial velocity, because we're now considering the system B to C. So its initial velocity is 1. Its mass is 0.06 kgs. C's mass is 0.12 kgs. So M3, we'll call that M2, doesn't really matter. And initially C is at rest, so U2 is going to be 0. B hits C. After the second impact, B comes to rest, so its final velocity will be 0. Find the speed of C after the second impact. We're looking for V2. So M1U1 plus M2U2 equals M1V1 plus M2V2. So 0.06 times 1 plus initially C is at rest, so that's going to be initial momentum is 0. M1V1 is 0.06 times 0 because it came to rest. B comes to rest, so that's just going to be 0. Plus the mass of C is 0.12 times V2. So 0.06 equals 0.12 V2. V2 is 0.06 over 0.12, which will be 0.5 meters per second.